Yo. Hey. Hello, people. Let me just refresh something real quick. There we go. All right, welcome to another day of Advent of Code exercises. Yesterday I did finish day 3. I'm not sure if it's worthwhile checking the final solution, but well, here it is anyway. Let's see where we at. So for solving the first puzzle, where we had to figure out what the shortest Manhattan distance was to an intersection of two wires, I first parsed the text that has something like R2 or L whatevers into these sort of commands, which I called wire directions. And then from these wire directions, I sort of applied it so that I could get in return a list of positions that the wire went in. And then I did it for both wires. Then I found the intersections, for which I still need to thank Ich bin I, the viewer, to give me the hint that I should probably use quadrants and only compare these quadrants, just to shorten the amount of positions that I needed to compare. This could do with some a little refactoring though, like extracting this into a function. And then we finally, which was this thing again? Right, so calculating all of the intersections. And then once I had the intersections, I mapped it to all Manhattan distances to 0.00, and I took the smallest one, and then there we have it, solved that puzzle. And then exercise 2, I started off by also writing down what my plan was, and I ended up skipping these because I gained new insight. And the insight was I don't need to apply until, because I already have the amount of steps that it took until one specific position, because I kept it all in a list. So that's what I did here. Where are we at? And then finally merged all of the intersections, and then made sure that I just got the position with it. I mean not the position, but the amount of steps that it took, summed it, and then also got the least of this. So grouped by the intersections and then the amount of steps, and totaled that. And that solved day 3. And today we're going to start doing day 5, so we're skipping day 4. Why is that? Because we decided at work that we were going to discuss day 5. And I think it's day 3, day 5, and day 6 that we were going to discuss. So there we go. So let's read up on day 5, shall we? So we sort of missed the lore on day 4 here, but I think that's quite okay. So the thermal environment supervision terminal starts by running a diagnostic program, and the test diagnostic program will run on your existing int-code computer after a few modifications. First, I'll need to add 2 new instructions, so opcode 3. I think we only had 1 and 2, and then 3 now it takes a single integer as an input, whereas 1 and 2 both are taking 2 input parameters, and saves it to the position given by its only parameter. Okay, for example, the instruction 3,50 would take an input value and store it at address 50. which would be the input value though. So then opcode 4 outputs the value of its only parameter. For example, the instruction for 50 would output the value at address 50. We'll come with documentation that explains what should be connected to the input and output. The program 3,0, 4,0 outputs whatever it gets as input and then halts. Okay then. And then second, you'll need to add support for parameter modes. Each parameter of an instruction is handled based on its parameter mode. Right now your ship computer already understands parameter mode 0, which is position mode, I guess, which causes the parameter to be interpreted as a position. If the parameter is 50, its value is the value stored at address 50 in memory. Until now, all parameters have been in position mode. That's correct. Now your ship computer will also need to handle parameters mode in mode 1, which is immediate mode. And in immediate mode, a parameter is interpreted as a value. If the parameter is 50, its value is simply 50, so not at the position 50. There we go. Parameter modes are stored in the same value as the instructions opcode. And then the opcode is a 2-digit number based only on the 1s and 10s digit of the value. That is, the opcode is the rightmost 2 digits of the first value. I need some examples of this. Parameter modes are single digits, 1 per parameter. Read right to left from the opcode. What? For example, consider the program 1002. So I guess this is the, well, just this thing here is the opcode. 2-digit number. The rightmost 2 digits of the first value. Rightmost, so that's this. This will be the opcode. So this is the parameter mode. The second parameters mode is in the thousands. Oh boy. And so on. Any missing modes are 0. It's a multiply instruction because it's 02. Then going right to left. The parameter modes are 0, so this is the first one. And then 1. And then another 0. Ah. It's, I don't understand the and so on then, because okay. And somehow they also call them A, B, C, D, E. Mode of the first, second, and third parameter. This instruction multiplies its first 2 parameters. So I think these are the parameters. So first parameter 4 is in position mode, and why is that? Because 0 is position mode. So this is the first parameter. It'll go look for the value at position 4. So that's 0, 1, 2, 3, 4. So that's 33. And then the second parameter is just 3, not position 3. So that's 33 times 3. Yeah, okay. And then there's still a 4 here. And what does that thing do? Ah yeah, written to address 4. parameters that an instruction writes to will never be in immediate mode. This output thing for multiply is never in immediate mode. Some notes. It is important to remember that the instruction pointer should increase by the number of values in the instruction after the instruction finishes. The instruction pointer. All right. So that indeed it's no longer always 4, and then I can't use chunk anymore. Integers can be negative. This is new or what? But only if it's immediate mode, probably. We'll start by requesting from the user the ID of the system to test by running an input instruction. Okay. Non-zero outputs mean that a function is not working correctly. Check the instructions that were run before the output instruction to see which one failed. What? This final output is an error. An output followed immediately by a halt means the program finished. If all outputs were 0 except the diagnostic code, the diagnostic program ran successfully. Okay, after providing 1 to the only input instruction and passing all the tests, what diagnostic code does your program produce? Let's get this already. There are negative numbers here, so... Oh. So since it's a copy of day 2, maybe it'll be best to copy this module and call it day 5. And then I'll... Yo, what the hell is this? Oh. That was a bit silly. Don't copy build. So let's do that again, I guess. Day 5. There we go. And then we'll add our settings and we'll add day 5 as a module. Then because we did this, we'll have to refresh our Gradle project so that IntelliJ can learn that this is indeed a module to the Advent of Code project. And then I guess what we can do here is rename it eventually. Say day 5. There's still a bunch of stuff in here that is a bit unclear to me. I also miss a little bit of test patterns, but we can always come up with them ourselves, I guess. Okay, now let's open day 2 in day 5. And then rename that to day 5. Same with for the test file. Okay, and now I think instead of just deleting all of the things, let's not do that anymore. I forget where I solved day 2 or the two-parter Oh yeah, I remember now. That was just a brute force kind of thing. So we can get rid of that. Then our actual input, let's get it. There we go. And then we can probably just commit this, right? We can get rid of this too. I suspect we are going to have to get rid of all of this. I mean, refactor it. Okie dokie. So, initialized day 5. How's it going, everyone? Is it just as rainy where you live? Alright, we can push this already. Okie dokie. So the first thing I think we should do is make sure we can cope with these different style of int codes, or what are they called? Opcodes. Do new instructions. So next to addition, multiplication, halt, and no op, we're going to have to add 3 and 4, which is... I still wonder how this works. Takes a single integer as input. Like, where does it say 3? I want an example with 3. So maybe one instruction is input and another instruction is output or something. And then parsing is going to change as well. Because this is not correct anymore. I still think we can favor parsing it first though. So in our solution, parse input. So this chunked we can't do anymore. So we'll have to gradually run through this list and then map it to instructions. Oh, and then these are possibly not parameters. I mean, they might not be addresses, is what I wanted to say. That's right. So maybe what I should do here is make these a type alias of address, just to make it a little bit more clear. Or explicit. Yeah, so let's first test this parse input method, because I think we have that. Parsing into opcode. So this is the actual parse input thing. I really wish I had some extra examples here for tests. So this is one valid program where we have to find the value at position 100. No, it's just 100. And then add -1 to it because it's the addition. And both ones are immediate. So that's 100. Then that's -4. And then put it at position 4. So that's 1, 2, 3. No, 0, 1, 2, 3, 4. Okay, so this is already a good integration test, let's call it. I constantly have the feeling that I'm being distracted by this. But the rest of the logic it remains the same, I think. So the list cannot dynamically grow, I mean the memory. So that's a good thing. So we can still maintain our approach from keeping 2 lists, one for the memory and then one instruction array, let's say. And these are called instructions. So everywhere there's that, I now want instructions. Instructrions. There you go. Some renames plus introduced address type alias. There we go. All right, and then what we have is an older parse input. So let's give it a new one. I think that's an actual program here. Can parse new input or something. So what do we have here? We've got an addition of, well, I guess 100. Then a -1, and the destination address will be 4. And then there's no halt there. All right. So what we need to do now is change this thing into or something that's a parameter instead of just an address. So what I'll do here, so the destination thing can never be not an address. Let me sneeze for just a second. Ew. Yuck. I'm sorry you had to witness that. So let's just call it parameters. Both of these will become parameters. And then a parameter is something that's making me sneeze. It's likely that there's a third one on the way. Let's also make that a sealed class. Maybe, or a data class. Let's make it a sealed class. And then one of which is a, what did they call it again? Mode. So it has a mode and it has a value, I guess. So mode, which can be one of was immediate and the other one was called position mode. Maybe call it parameter mode. And then parameter mode is maybe an enum. And then it also takes a value, which can be either an address or damn it. Either an address or an actual value. And I think I want this to be some kind of type. Parameter value, or it's always going to be an integer. And we have not an object, I guess it's a data class address that has a value. And it has just a value, I guess, which looks exactly the same. Both of these can go. Bless ya. Thank you, Kun. I read that quite late. So here we do know that it is indeed an actual address and not just a parameter. Right, and then this is going to be a parameter value. And now we have either a position or an immediate parameter, I think. So instead of doing this, I'll... No, I don't need this. I want a data class called immediate. Which has a value. And it's specifically a value. With a value. And it will have a position 1 which also takes a value. But here we have the address. Okie dokie. And then so for addition, it depends, I guess, which kind of parameter it is. But here it is an address as a destination address. And then same for multiplication, we also need to refactor this. But why don't we? Now I need to change this immediately. Yeah, tju toch. This will definitely not become from a list of max for ints. There's no longer a way to do this. In fact, just to produce a 1. I think what I could do is return a pair of an instruction and then a remainder of the list. But yeah, we'll see about that, how we're going to tackle that problem. But what I want to do first, though, is make sure that we can create an addition. Let's also actually just do these like that. There we go. And then so that's going to be parse input. That is that I'll need to change now. Well, this is no longer true. This needs to go as well because it doesn't make any sense anymore. Yeah, I think we just need to rewrite all of this. So now there's 3 and there's 4 that we need to take into account. And then, yeah, we also won't need no operation anymore, I don't think, because at the end of parsing the entire list of int codes, we need to have a full list of instructions. Okay. Let's change this, convert the block body. And then I think what we should do is start testing this parse input. Ah, yeah. So now this is no longer just 100. It should be let's see. So since it is immediate, I want this thing to be an immediate parameter. So maybe what I do want to do is just make an integer out of this. going to go ahead with that. Yes, I'm going to add another constructor that says here's an integer, and you should return this, and then create a value out of this. It doesn't take a val, of course. Now this thing should compile. Yep. And I think I'll do the same for position. But here it needs to be an address. I wonder if I can get rid of this, in fact, now. Oh, no. They are both private, though. Otherwise, I'll expose that thing along with it. Don't want to do that. Same here. So now I've just been making sure that my type system is good. So for the second one, it's also an immediate. And then this needs to be an address. Okie dokie. Okay, cool. And now I'll need to get rid of all of these tests, I guess. It's really just rewriting everything. Christ. Is it TDD? No. Why not? Well, it is test-driven development in the sense that I'm creating tests, but I'm not actually doing test first. That's a good question. Or I mean, it triggered me to think or whether or not I should just kill all of this and start TDDing again, because I mean it will look completely differently than before. I guess I already have my entire solution anyway in day 2. Were you using TDD before? Yes. So the exercise I did yesterday, so I solved day 3, I think. Yeah, that was day 3. We solved doing test-driven development. So that's my standard mode, let's say. I think I'm looking for a way to Effie Pasha, thank you for following me. I wonder what we should do here, just to make sure that I can just delete stuff that's not compiling, right? And then just test drive the rest, because I can always go back to day 2. This is just the fear. It's the fear of deleting code. So all of these are going to return int codes eventually. But you know what? Let's just return. And what is int codes? I think it's a class. So maybe return of an empty list or something. There we go. There, it compiles. Yay. Let's also get rid of a bunch of stuff here. So executing instructions. I think these test cases though, they're quite fine. So what I think I'll do is I'll leave the test cases themselves because I think they're still relevant. However, they're going to look quite differently now. All right, and these are results even. Okay. How am I going to make this compile properly? This just doesn't exist anymore. Applying addition, applying multiplication. Maybe I can already fix these though. Fix these tests. Or no, let's just get rid of them. Because they're going to look differently, right? And then no assertion. There we go. This example is also going to change. So maybe let's replace this with a to-do. Figure out good example. Or actually, let's do to-do rewrite as new instructions. Something like this. And here's a solve exercise 1. Let's just not do this. Or I think what we can do is just get rid of the test and then it's no longer interpreted as a test. All right, now we can start doing a bunch of cool stuff. Right, we were going to do parse input so that we can parse the input into new kind of instructions. And this is an example we got from here. Here we go. Store the result in position 4. And I think if I run this now, it should definitely fail. So I want an addition with immediate value 100, another immediate value -1, and then store it in address at 4. There we go. So there's a single instruction, I think, that's supposed to get out of this. The other thing I don't know how the 0 at the very end is a valid program. Because there used to be a 99. Where 0 means the test was successful. And this is also stuff that I haven't set up yet. Finally, the program will output a diagnostic code and immediately halt. So I don't think we still have a 99. Or it does actually, yeah. I'm mistaken. The program 304099 outputs whatever it gets as input and then halts. So I really don't understand how this is a valid program. This one, for example. Plus, I'm also unsure. They say here, where was it? Like the and so on. Oh, here, and so on. So does that mean any missing modes are 0? Like, how many parameters does a thing get? Actually, it is up to 4 then, because we've got multiplication, addition, and then nothing anymore. Hey, number 715209, what's up? How are you hanging? Maybe you can help me out. I've got this thing where I don't know what this means. Maybe I should like write it somewhere. Questions that I have. Cuestiones. It says and so on. So are there an infinite amount of parameters possible? Or am I just silly and it depends merely on the sort of instruction in the to rightmost digits? No idea. That's okay. All right. So, this is one little part, right? Because we've got, yeah. I feel like I want to create a longer test case than this. So maybe I just want to I think it's hard to keep on trying to pull stuff. Maybe I do need the no-op for now, actually. Just to make my tests easier to write. This is incorrect. What is Advent of Code? I'm glad you asked. Advent of Code is a recurring event, yearly event, created by Eric Wastel. And he provides puzzles every day during the Advent, so that's starting from the 1st of December until the 25th. And every day you get a nice coding exercise, and you can solve it in any language that you want. Here's like the way that he structures his puzzles, which is, I mean, it's fun because it's always Santa related. There's some lore there, so that's fun. And then you solve it in any language that you want. For example, my colleagues and myself have been doing this Right, where are these forks? Here we go. So these are all my colleagues. They all forked the same thing. And then Bruno and Boke are doing it in Python. So this is their solution for day one. It's pretty concise, as you can see. But then I think Koenraad is doing it in Go. No, Rust, sorry. Rust with WebAssembly. That looks really cool. So there we go. It's a bit less concise, but it's cool nonetheless. And then what we try to do is come together on Tuesday and then check check our solutions. Basically, that's it. But so today, day 9. It's already day 9. Shout out to Sean Plot. But I'm doing day 5, which is extending the exercise of day 2, where you built an int code computer and parsed instructions so that I can then apply those instructions to the memory that was passed along as well. Right. And now it looks a bit different here. So we gradually need to parse this code. So the first 2 rightmost digits are considered the opcode, and then after that, or to the left of that, the first digit is the mode of the first parameter, then it's the mode of the second parameter, and then it says the mode of the third parameter, which has to be which in this case for multiplication is the address where you need to put something, and it should always be position mode. But it could theoretically be immediate mode as well. But we haven't encountered an instruction yet that does that, so yeah. So anyone can play along. It's my sound is a bit low. Well, that's not good, is it? I can always make it a little bit louder, I think. Just let me know if this is better. Thanks for your feedback, by the way. And hi, Boke. How you doing? I was just struggling with how I guess how I'm struggling with getting rid of my tests that I had for day 2. And then this is a question as well I had. So I don't really know how to do this. I think what I'm going to do here, I just added no op again, just to make my tests a little bit more easy to run. It doesn't need brackets, of course. Still very low. Oh, compared with Spotify. Well, in that case, I should probably turn down Spotify a little bit. Like this. Oh my god, people keep buzzing me. Just, this is crazy. Silent mode engaged. Okay, cool. Oh, you can hear me just fine. Alright, cool. Right, so this test, if I run it, should fail. Because then parsing new input into instructions ain't gonna work, because I threw away my code. You know, somehow it always takes a little longer to run it the first time, but afterwards it runs it a little bit faster. There we go. Yep, all right. Let's just try this one. Or do we want to continue adding more tests? Because this can parse into an addition. Maybe we can also already do multiplication, for example. Multiplication. So that would mean this thing. Okie dokie. Here we expect multiplication. Maybe the other thing we could do is do the two different modes of input. So let's in fact inline this maybe. I think somehow I missed a brace there. Yeah. Let's first inline it. And then duplicate it. So this can remain 1. A 2 would mean multiplication. And then I guess 3 and 4. Wait, no, that's not what I wanted to do. I wanted to remain this as a 1 so that addition remains here, but I want this thing to be a... I'm a silly man. Silly man. Let's do position 01 the first. With a 0 here. So this turns into not an immediate, but a position mode. I feel like I want to rename this to position mode or something because, and same for here, because I already have a position from in my common class. Okay, so now I have two parameter modes, one being position and one being immediate, and then the output. What am I making? Motorcade asks. I am trying to solve the advent of code day 5, sunny with a chance of asteroids, where we are extending the day 2 solution with new operations or new instructions. And we'll need 3 and 4 as opcodes here. And we were just making some tests to make sure that we can actually do that. So this is what I think should be the result of addition. Why is that? Because these two signify the sort of operation or sort of instruction that we're about to do. And then following that to the left. So this thing is position mode, and this means immediate mode. So basically add the value at address 100 and add to that -1 directly and store it in address 4. That's basically what that thing says. And here we've got multiplication mode where I want to do the same. Maybe here I want to do so immediate mode 100, and then what I can do here, I think, is leave this 0 off because it implies that leading zeros are my god, this is going to be so difficult. So it should turn to position mode, because that is what the 0 signifies. And I don't think that can be negative, so let's just make that into, I don't know, a 2 or something. And then again, store it in address 4. So here, what we're testing, in fact, is the leading zeros turn into zeros for both position and address here. Now I'm thinking maybe I should transform this thing into position mode as well, which will make it a little bit more clear. Let's do that, in fact. So instead of directly an address, let's add a position mode here. And then we'll need to change these into position mode. There we go. I think both tests are going to fail, of course. Wondering how y'all are doing on this Monday afternoon. All right, we're getting empty lists here, so let's try and implement this now. So this is the function that I have under test right now. I've got a bunch of ints. Which, come to think of it, might not be very smart. Because I'll need to find something like the rightmost 2 characters. Just got home and wanted to see some programming. That's great. What do you do for a living? 715-209? Or maybe you're studying. Okay, so I think what I can do is just parse the first input. Let's just do it very gradually. So if it's not empty, then this is the thing I want to parse into an instruction somehow, or start parsing this into an instruction. So let's just call it just that, instruction to be parsed. Pards parsed equals encode, just like that. Studying programming, that's cool. How are you liking it so far? Is it like, oh god, these teachers? Or are you feeling like you're learning something useful? Because it sure was different back in my days. Right, so what I want to do now is I want to create an instruction from this thing. So I feel like what I want to do is get the first, well, the 2 rightmost things from this. I really do want a string instead of an integer now. And if I look where this is called, it's right here. So maybe let's not use int code here. I don't think, oh. The other thing I could do is make this into an int code, of course, and then I think that's what I'll do. Yeah. And then these can become int code types. And what I can do then is execute an int code using this instruction. Because I don't think I actually do operations with them. Yeah, if I do, if I execute instructions, I'll use this as an integer, in fact. But it's only, yeah, that's the thing. I only move it to, I should only parse it as an integer the moment it actually gets used. So that's also changing now. Oh, I made too many assumptions when I first made my initial solution. It's going all right. Still in your first year, haven't learned anything I didn't already know yet. Sounds like you've got a lot of advantage over your fellow students then. That's a good thing. That means you've got a bunch of options, huh? You can either... so let's make these strings. You can, what I think you can do is you can either continue learning, like staying ahead of the curve, and then, or you can gradually come up to the same level, or have your fellow students come up to the same level as you yourself. So these will also take strings now. So that means, no, I am mistaken. This should be an int code, which I haven't defined just yet. There we go. So here, I don't think I want to parse into instructions yet. I think I want to parse into int codes. And this is an int codes thing then. So I want to write this function. And to do is fine. And then I want to test that thing. Parsing into int codes. Strings get turned into int codes, basically. This is the function I want to test. It'll take an input, which is this thing. And then what I think I want to do is turn these into strings, and then of course I forgot the minus there. There we go. And then assign this to int codes, and then I can assert that these int codes contain exactly, and then a bunch of int codes, right? So all of these with int codes. That means I can do the same again. Oops. and then map them into, oh shit, I had it, an int code from that string. That's basically what I want to do. And then let's create this data class back in the implementation here. Data class int code is going to take private internal value or something, I don't know yet, string. That's about it, right? Ah, contains, exactly. You wanted to try learning C. That's cool. All right, so that should be that. Then I can start fixing this so that it no longer is a list of integers, but rather a list of int codes here. Boy, that's going to be annoying. Maybe I can, oh, actually. Maybe I should have immediately, why do you have a huge gap on the left? What is the huge gap on here? Ah, because this is presentation mode. So if I go out of presentation mode, it looks like this, but it becomes unreadable to you guys. So that's why. Let's see, where was I? So maybe the only thing I needed to do was actually have this constructor there, and then parse into int codes becomes too easy. So I don't need CSV lines as anymore. I think I just need CSV lines. Yep. Didn't know about presentation mode. Why don't you just zoom in? Because if I zoom in, let's open a bunch of files and out of presentation mode. So here I've got a bunch of files open, right? Let's say I zoom in on this one. The moment I move to another one, it doesn't have the same zoom in level, let's say. So IntelliJ doesn't keep the same consistency there. So I don't like that at all. So that's why there's presentation mode. Plus it also makes you, it provides you with less buttons all over the place, and just a more clear UI, I think. It helps you practice your shortcuts. But the annoying thing with presentation mode is that you cannot close files. So if I close this one, okay, they definitely fixed this. This is new to me. They finally fixed this bug. It's been in there for ages. It used to be that if you close the file in presentation mode, it would just bring you back to this screen and always this screen, but only if you ended up here. So that's why I kept on switching with Command E. Oh my god. Oh my god. Thank you for having to demo that to you. Because now I no longer need to do that. We were testing a bunch of stuff here. So maybe we can just return 0 here and make it compile. And now I automatically go back to using Command E. Yeah, let's not do this. Just comment this stuff out. Make sure we can test one thing at a time. Shall we? Okay, so run this. I'm not sure if I even implemented it yet. No, it should completely fail. A doo-doo, of course. Maybe let's just return an empty list and see it fail for the right reason here. Oh, so I think I can do that. In fact, I used contains exactly because I wasn't really sure. Yeah, I can, because int codes is a list of int codes. That's great. So then what do I do? Basically return int codes and I map it using the int code constructor. I'm actually not sure how you do that. Is there a way to write it like that? No. No. In that case, I'll just write it like this. And then wrap this in an int codes object. There we go. Now if I rerun my test, I think it should work. Yeah, because int code is indeed a data class. It has 0 functions for now, so let's get rid of those. All right. Well, there's that. Cool. Now I can start using this again or testing this again. So what I should have done, in fact, is also make sure that if you pass an empty list, that there's an empty list of int codes here, or have it explode, but feeling a bit lazy. Can parse new input into addition. Cool. So now we no longer need a list of this, but I want to transform this into an int codes thing. So it should look like this. And then I think I want an easier constructor than this. Hey. But maybe just for tests only. Okay, so what I'll do is I'll create day 5 test helpers or something like that, or test builder. And then I'll create an extension function. But really what I can do here is something like this, and that takes a bunch of strings. Is there like a way to do variable arguments? I keep forgetting. So that's not something that I wanted to do. Var arg strings. Cheers. And then I can map this into int code it, and I can wrap this in this thing and just return it. And I think I can just go something like that, and then use this. But then with strings. There we go. This makes it already a little bit more readable, I think. What? Parse input requires strings? I don't think so. So this now takes an int codes object. And then I can, there, now it compiles. And then it should contain this. So let's run it. I think it should fail, because I'm returning an empty list. There we go. Okay, now we can start transforming one of these int codes into an instruction. There's like this take while thing. So I think what I can do is gradually build up my instruction until I either run out of int codes or encounter a halt. Right? So this is maybe it should be a no op or something. Take while instruction from int code it. If there's a no op, oh no, I also need to build this thing then, instead of just yuck. So if I were to make an instruction from this thing, I think what I want is to split this into like an operation or something. So first figure out the operation. Yeah, let's do that. So we'll have another class thing called operation. should it take something? I'm not sure yet. Maybe it's not an operation. Let's call it like this. Just create this thing. Sure. Sure. We'll figure that out later. So if, or actually, yeah, if it equals, or actually no, the last two digits. I think what we could do here is addition is an operation, maybe. We can just return that. That will be fine because we already have an object here instead of just a string. So in that case, that'll be easier. Then we can just ask take while it is an operation. Yay. And then we'll create this thing. When is an encode an operation? Take while going to eat the input. I think so. Because it returns a new list. It's not a stream operation though, so it might not. I'm not really sure. What would happen to the written outputs of previous operations? No! Oh no. Oh no. I can't just parse it anymore. No. The reason why is because before it used to just be position modes. So the only thing I needed was keeping track of the addresses, so I could have delayed execution. But now, because I've got immediate mode means just use that thing as a value, but this -1 might have just been overwritten by some operation that changes something. Maybe I can write a thing for that. So this would mean if I am applying an operation or an instruction to a parameter that was changed by a previous instruction. That's the thing I want to test, right? So in this case, we've got an encodes thing where we will have, let's think. So we want, for example, an addition. We want our first, no. So for this, it doesn't really matter. So let's make 2 immediates. What are the parameters? Let's do 2 and 3 for now, and then output into 0, 1, 2, 3. So here's going to be the next operation, which might be another addition. So that's 4, and then I think I want to change 5. And then 5 here, let's also add that. You know what? Let's make this into this. And then output into, I don't know, doesn't matter. So that means, let's add it as an enter thing. So we've got an actual instruction, an operation, which takes this as a parameter and this as an address where to put it. So 0, 1, 2, 3, 4, 5. So this statement will change this into 5. And then what will happen is I'll do multiplication with 2 immediate parameters. So this will be 5 and this will be 10. And I want this output in this thing itself. So that's 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. So if I execute this, then that means a Kotlin 45. Thanks for following. So here, I think the result or the output, how do you call it? So my memory at position 7 would be is equal to 5 times 10 and not 0 times 10. Christ. Let's actually put it in here maybe. Because I think here I was just changing my memory a little bit. So what I want to do is make this an end test case. Example where applying an instruction to an immediate parameter that was changed by a previous instruction. Yeah. Balls. All right. Thank you for the pitfall there, Boke. That would have been extremely painful. Damn it. So that actually means I can't just parse it first and then apply it. Me. So that also means that as I am building that operation, when I detect that it's finished, I immediately need to execute it. So you were hesitating, did not want to spoil too much. You didn't spoil too much, but thank you for helping me out with that. And also phrasing it like that, because I also couldn't have, I could have just ignored it. Damn it. Now I'm wondering what the use is of all of this, because I'm thinking on an approach on how to take this, deal with this problem now. So I think parsing into int code should be fine. So if it's basically doing this, right? Take while. No, I am incorrect. Maybe what I can do is reduce it into instructions or something. What font are you using? GeoWiz asks. It's a Fira code I'm using. It has ligatures, so you can do this thing. So I think what I want to do is go like I'm gradually building a result. So I want my memory to be updated. I think and that's basically it, no? I just want this to be updated. State. And then gradually build up an instruction when it's complete. Execute it. And apply it to memory. So you can't do this in a loop, I think, because you're changing the values in the loop. I mean, changing the values of the list that you're looping on. So this is a thing I'm struggling with now. How do you gradually build an instruction? It's basically what I was having here, to parse input. Okay, so maybe I want statements then, or instructions. Gradually parses into an instruction. So what we can do is just do something like this, for example. Okay, let's inline this and then make the steps real explicit. So we've got 1, 2, 3, 4 of these assertions. 3 more. So the first thing, what I can do is always get rid of this stuff. So I think it should look like this. I'm not really sure. Then it doesn't have a no-op. Then we'll get rid of these. That means I don't have an addition yet. And I'm struggling on how to make that thing explicit. So I guess maybe make it optional or something. Damn it. Okay, let's try that again. So we've got this, and then both of these. I think we can always grab the first parameter though. I mean, that should always be there. So for all of these question marks, I guess the default will be null. And then it does compile. And then this last thing will become something like this. And oh, I don't know why it's suddenly 100. I guess I deleted some stuff. Because this indicates it's an operation. It's an addition, sorry. And then it's an operation with the first parameter being a position mode of 100. Then if I gradually increase the amount of things there, we'll get 2 arguments. One is in the position mode, and then another thing is going to be immediate mode for this thing here with a value of -1. Yeah. And then I think here we want to execute the addition instead of providing a no-op. So what is the result of parse input? In fact, it should be execute. This is horrible. Because I need all of the components all at once. So what I was thinking about doing is maybe we'll keep a computer that has initial memory or something. And then I want to execute the encodes basically on that thing. And I think what I could do is ask, hey computer, give me your memory. And then compare it to get an actual result there. I have a feeling you're doing a lot of abstractions at once. I also have that same feeling. I think it's because in day 2, I taught myself this concept of instructions and whatnot. And I feel like I want to remain in that world where I knew what I was doing or where I thought what the problem was. But I think day 5 just looks sort of the same, but it totally isn't, especially not according to the solution that I had back in day 2. Just wondering how I can split this thing up into... you know what? Maybe let's do this execute or something like that. Instead of the no-op thing. There we go. You had to take your headphones off, so I didn't hear if you reply. Yeah, I did reply. That's okay. Thanks, Broker. Yeah, let's try this. Gradually parses into an instruction and executes it. So maybe we can keep this for later, and then let's do that. Parse input, which is definitely not the right name. Executes when detecting an instruction was completed. And here, this thing will actually change. Oh my god. Yo. Peace. I feel like I can make this work, no? So we definitely want two things now, right? We want a memory and int codes. Let's just do it like this for now, and then I want to... So this really should just parse. And then parse input with int codes. And I also want to apply memory to that. So parse and execute. That's what it's called now, I guess. Yep. let's see how our test. Yeah. Well, it should definitely be the same. Hello, IntelliJ. And should it return the memory? Yeah, I think so. Yeah, gods, this is so difficult. I can't wrap my head around doing parsing and executing at the same time. Okay, maybe what I want to do is spell it out in some text file or something. There we go. So if we have something like this. Given. And I want to apply this or whatever. Then the first thing I'll do is I will look at the first thing. So parse 101. That'll result in memory still this. And then instructions or something like that is it's an addition. Then comes the next thing, which is the 100. Then my memory still is the same. But now it's addition of a 100 because it's well, with the memory add, so value add something like that, I don't know. Then let's see, it's the next thing is -1, then it'll be value 8. It'll become an addition with value at 100 and then just -1. And then we've got 4 and this is our destination. So memory still hasn't changed, but the instruction now has destination at 4. And then maybe, let's say there's a next instruction here or something. So then we'll parse this. So when this thing gets parsed, then what I think I should do is execute this addition thing. So that means my memory suddenly becomes something else. So let's say value at 100 is I don't know, 3. So put that at 4, that means 0, 1, 2, 3, 4. That can't be right. So maybe let's make 4 into 3. And now my instructions should stop, in fact. Maybe it's always just a single instruction that I'm building up until I'm able to execute it. So the result of this should be, so at 3, we'll have 3 minus 1, that's 2. And then comes the next thing. So we'll start multiplication with nothing. So that means that there's no longer multiple instructions that I'm doing. It's always going to be a single one that I'm building until it's ready to be executed. If that makes sense. So this 3 is position 100, huh? Oh shit, I need to quit real soon and make food. Damn it. I'll never be done before tomorrow. Maybe let's call this current instruction or something. So I think what I want is that this here looks like this. So a combination of memory and instruction. So what I can then do is make this into a computer that takes in this as arguments, and if I then execute it or something, I can always ask the computer or something like, what is your memory and what is your current instruction? Something like that. That should be okay, right? All right, let's just try that. Let's give it this memory. And then we'll computer.execute. And then I can always assert that computer.memory is something. And it shouldn't change here. And then when I ask for current instruction, that it's equal to just an addition, just for the first part. Yeah, we'll need an additional step for that, in fact. Now maybe I don't want just execute. Maybe like an internal function or something, because this seems like it's like the main thing that you want to start. I don't want that. So maybe I only want an apply or something like that. Let's call it. It's just partially execute. And it should take, this is the memory, right? And the current instruction maybe. And then we can just return both. And I'm not sure if contains exactly also works on a pair. Jesus, I'm having a hard time with this. So I guess in the beginning this is nothing. So maybe just null. So here we've got memory and then an instruction, which is an optional instruction. And then the result should be a pair of an encode string and then the current instruction. Yeah. And contains exactly does not work on that. Okay, cool. I guess we can do this. Now I do need to make addition, the first thing, optional. Like that. And then it should be, I already forgot which thing was first. So int codes and then an instruction. So that means memory to addition. Okay. And then both of these contains exactly should be changed to is equal to a memory 2, and then this thing. And then instead of doing this, in fact, it should always just be memory. And then it changes. So here we have just an addition, and here we have this addition. This is impossible to read. Oh, right. And then I need to make sure that this memory remains. So that's -1. And then, what was it? 3. And maybe I want to read number 5. So that's 2, for example. So instead of the 100, we'll get 6. So 0, 1, 2, 3, 4, 5. Of course, I needed 5 instead. So this should show that when I do partially execute, I keep my memory and I build up a current instruction until I hit this thing. And also memory changes at that point. And then the question remains, do I want to already execute it here, or is it in the next step that I want to do that? So I think if I were to execute this again, it would become a multiplication instruction. Actually, it should become this. And then memory changes after addition. This should become, so the thing after at position 5, so that's 2 minus 1 equals 1, and put it in position 3, so that's here. So that's what it should look like. So that's what I expect it to become, and then the next thing is multiplication. All right. So I think that'll be that. This can go. All right. I think this is going to be something that should work. And I think I'm going to commit this, and then commit and push this, and then maybe continue working on it tomorrow. At least now I have got yet another plan than the one I had before. Whew. Programming is hard. For me, at least. Memory. And then null. There was another. Oh yeah, we can get rid of that. Okie dokie. Cool, let's commit this. Wow, completely had to change the solution. Design. All right, I really gotta go make some food before I have to leave my home. I wish I started this thing earlier. Dang it. All right, as usual, thank you for watching. I hope you had a good time. I did, learned a lot. When am I going to see you a lot? Next time, I think. Might be tomorrow morning already. Yeah, let's make it tomorrow morning. All right. See you then. Till then, have a good night. Peace. Let's also maybe find someone to host, shall we? Be a nice person.